is when it's not just something, something, something is less than something, or something, something, something is greater than something. That is a simple inequality. Something like this. X plus 2 is less than 4, right? That could be a simple one. 12x is greater than or equal to 2x plus 8. I'm making this up, so don't look for that. Those are simple, basic, normal inequalities, okay? I'm calling them simple just because they're sort of one step. Combined is slightly different. It's kind of like saying Mrs. Myers is older than Mrs. Doris, who is older than my daughter. Okay? That is a combined. Myers is older than Doris, who is older than Rebecca. Okay? This relationship is what a combined inequality looks like. All right? It's when multiple things are being compared, and there's a couple of different types of comparisons that happen. For example, if we look at the Cinema 5 theater or Cinema V theater, the general admission price is $4.50. Kids 12 and under or senior citizens are half price. Therefore, you must pay full price if your age satisfies both circumstances. So in that little story, you pay full price if your age is 12 or under, so greater than 12, and if your age is less than 65. Okay, so somebody whose age falls between those things pays full price. The rest of those people will pay a discount. In any case, this word "and" is a conjunction. English terminology, crossing over. Conjunction is when both inequalities are true. Okay, and they're calling them both sentences here, but we're talking about inequalities. All right? This first example is quite simple. It says, graph the conjunction something and something else. I'm trying to find one that's not the exact same one in the book. So we're going to graph z is greater than -1 and z is less than 3. All right. This is where the little trickiness comes in. What just happened? What did I do? Interesting. I have no idea why that did that. Okay. That was weird. All right, so I'm not the only one that thought that got a little strange. Okay, graph these two things. First step is going to be to show a graph with those numbers on it. And I am extremely simple with my graphs. Okay? Make sure they're in the right spot. Obviously, the negative is to the left and the positive is to the right. Okay? If something is greater than -1, that means it doesn't include -1. Would you agree? And it heads in this direction. But wait, there's more. If something is less than -3, That means it does not include the negative 3 and heads in that direction. Which means to satisfy both scenarios, only those numbers located in between the negative 1 and the 3 would be true. Okay? Is 0 less than or greater than negative 1? Is 0 less than 3? Awesome. Is negative 2 less than 3? Yes, but it is not greater than negative 1. So you see, you could have satisfied one, but you need to satisfy both when it says and. Okay? When it says and, you need to satisfy both. That's a conjunction. A disjunction, on the other hand, is an either-or scenario. One inequality is true. It's kind of like saying, in order for me to get the discount on t-shirts, I either need to buy 100 child size or sell 500 adult t-shirts. Just making stuff up. Okay? So that means if I get 101 kid t-shirts, but only 10 adult, I get the discount because I've satisfied the more than 100 kid shirts.
Please go to the Genesis text. Thank you.
Folks, I'll finish the video off. I'll photocopy the notes, okay? We're going to keep going. We're going to keep going. Your assignment is posted, my good friends. Hopefully you logged it as well. All right. So disjunction is when one is true. The question is, how does this apply? How might this look? Maybe a question might be something like this. C plus 7 is less than 4, or 7 minus C is less than 1. Notice that or statement written there, making it kind of easy for you to see. It's an or. One of these must be true. So in this case, C is less than negative 3, right? Would you agree? Mm-hmm. And in this case, I'm going to add C and subtract 1. 6 is less than C, which means C is greater than 6. The big faces the C. So I can either have this or I can have this. And a graph might be that or that. Notice there's nothing that would solve this that would solve that anyway. Because look at, if it's less than a negative 3, it ain't going to be bigger than a 6. Okay, so this is an example of an or scenario. Okay, here's how it looks like without words. Example 2. Solve. Negative 2 is less than or equal to the opposite of x added to 3, which is less than 4. There's no and there's no or written there. So how do you decide? How do you decide? Well, I want to draw your attention back up to Doris, Myers, and Rebecca. If I were to say Doris's age, I'm 44, which is greater than Doris, who is greater than Rebecca, who is 12. Notice that all of these things are true, which means Doris is greater than 12 and Doris is less than 44. All of that is true. This situation, while it doesn't have names, is the same scenario. The question is, how do you solve a 3-part problem? You're used to seeing something, something is something. You're not used to seeing something is this, which is also that. So here's how you solve these. There's a couple of different ways to do it. The first way is to solve it as 2 completely separate circumstances. One that looks like this, and one that looks like this. Okay? That you all can do. Adding 3 gives me a 1 is less than or equal to the opposite of x. Since it's its opposite, x is, if you flip the sign, subtracting 3, wow, 5, negative, thank you. If you look at this as a coefficient and divide it out, you're going to flip your sign and you're going to end up with a positive 5, which we're not used to looking at it like that. We're used to looking at it, x is less than or equal to 5. Notice the pointy piece still continues to face the x. Okay? The other way to do these is to simply add the x and add the 3, and then you wouldn't have all this flippy flopping. That's why I usually add a variable if it's a negative, just to save myself the hassle. I'm going to do that here, and I'm going to add the x, which gives me negative 7 is less than a positive x, which means x is greater than negative 7. Does that make sense? Did I do my math wrong again? Jeepers creepers, lady. Plus 3, less than 4, negative 1, and negative 1. Thank you. Like I said, it's been a crazy day. Okay, if I solve it this way, I now have x is less than or equal to 5, and x is greater than a negative 1. Okay, solving it this way. The other way I'm going to share with you is a lot easier, but I'm going to do it this way anyway. So I'm going to start with my graph, negative 1, 0, and there's my 5. If it's greater than 1, it goes that way. If it's less than or equal to 5, it goes that way. Which means the 5 is a closed circle, the 1 is an open circle, and there you have it. Okay? That is the break it up, solve it, and combine your answers on a single graph. Okay? Your answers are between those two things. The other method, for the exact same problem, I like a lot better. I'm going to show it to you real quick. Negative 2 is less than or equal to negative x plus 3, which is less than 4. Solve it all in one fell swoop. Subtract 3, subtract 3, subtract 3. What? Okay, the 3 disappears from the middle. Negative 5 is less than or equal to the opposite of x, which is less than a 1. Right? We're not done yet, so don't stress. Remember your answer from before. It was a 5 and a negative 1. Right now I have this. Well, remember, that is a negative 1, which if we divide it out, it forces us to flip the sign. And you might not actually show that step, but just know that it's there. And now our answer looks like Mrs. Myers is greater than Doris, who is greater than Rebecca. Okay, so if you have a 3-part situation like this, you can simply solve what's here all 3 places. If this was a 2, which it's not, it's a 1, but you would divide all 3 places so that you get down to your x. Okay? That's an example of example 2, and this is how they do solution 2, which I just happen to like. It's faster. A disjunction is when 2 different scenarios are true, but not necessarily concurrently. So here's example 3. This isn't theirs, this is mine. Here we go. 3k plus 7 is less than 1, or 2k minus 3 is greater than 1. So it looks to me like the answers are not going to collide together. We're going to solve it. We're going to divide by a positive number, which means we don't flip our sign. Okay? So right there, we've got k so far is less than a -2. Over here, we're going to add the 3. And we end up with 2k being greater than 4, which means k is greater than 2. So either I sell something something or I do something else. They don't exist together because there are no numbers that'll satisfy both. There's your -2. There's your 2 open circles. Open circles. Okay, there is nothing that is greater than 2 that is also less than a -2, and you can see that on your graph. Okay? Today is just the first crack at this lesson. We'll go over some more of it tomorrow, and I have more practice items for you.